My poor dog's over here. He's like, I don't know what's going on right now. He woke up. So you're glutton for punishment and you want to build a CNC router, huh? Well, I did too, and that's what we're doing here. This video, I'm just building the base of it, sort of the platform for it, the table from the ground up. It's more or less a table, let's be honest, what you're going to see here. That's what you need though, right? But there is some differences between mine and a lot of people's. One of the big things is I'm using one X-axis ball screw. Now a lot of people will use two of them and one motor on either side and a ball screw on either side for their X-axis, right? Now to me there's a couple problems with that, and those being what happens if one of your motors skips a step on one of your sides. Maybe you're pushing the machine a little harder than normal or something. You lose a step on one side. Now your gantry's out. That's not good, right? And not just that, but your gantry alignment, the 90 degree, is reliant on your ball screws essentially, and not just the linear guides, and having a wide stance and being tight. So that's a potential problem for me. Now, something some people will do to get around that is they'll use two ball screws on either side, but they'll put one motor and link it together with chain or belt. I usually belt, but I have seen chain. That is definitely a way to get around that. Again, though, you're still relying on the ball screws. Even though you got one motor, if you lose a step, it'll still be in sync. That's not a bad idea, but again, you're probably losing some tolerance through your belt or chain setup. So for me, I just figured we'll make it real simple. The one ball screw under the table. But to do that, if we're going to make a big router, we have to clear span a large span, 8 feet, right? To get that gantry under the table to drive it. So we got to clear span quite a long ways. Now I have seen a couple of designs where people kind of take it overhead or do something funky to use one single ball screw to kind of get around having the clear span that full 8 feet. And that's clever, but for me, I just wanted something classic. I wanted the drive to be as close. When I was designing this has been the works forever for me in my head for years and years now, and I'm finally building it. But I wanted the drive to be as close to linear guides. I wanted everything centric as possible. You know what I mean? To me, that just makes it the stiffest and sturdiest. If you got your linear guides up here, but you're driving it way down here, you're putting a lot of leverage on your gantry and everything. But if you build it stiff, of course, it really shouldn't matter, and that's what I've come to find out is that probably doesn't matter that much, especially the way I'm building my gantry. It's extremely sturdy with huge box tubing and everything, steel welded together. So a lot of that's irrelevant, but you learn that as you go. Either way, I'm going with the single ball screw under the middle of the table. Now, stepper size, I bought huge steppers, 12 32-ounce NEMA 34 steppers. Now, that might be nice for the Z-axis to pick that up, but I got a feeling they're just going to turn into giant heaters, space heaters. We'll see. It's probably overkill. Now, there is one funky sort of statistic with stepper motors. The faster you drive them, the torque falls off like a rock, and the bigger the motor is, the faster that torque falls off. So these big giant motors, even though at 100, 200, up to 300 RPMs, they even started falling off at 300 real fast. 200 RPMs, they have a massive amount of torque. At 500 RPMs, it starts dropping a lot. And then if you compare a much smaller motor, NEMA 23, to this giant motor, like a 370 ounce inch one, at 500 RPM, especially at like 1,000 RPM, that tiny motor's got as much torque as this huge one at that high RPM. So you got to plan on not driving your motors very fast from the beginning. I'm glad I got 10 millimeter pitch ball screws, right, for the X-axis. I thought I got a 5 millimeter pitch one. I was bummed. I'm like, man, this machine's going to be so slow. But I did get a 10 millimeter one, so that'll help drive it faster. I've calculated I can probably do 200 inches per minute with this machine, very reliably and accurately. Probably that's probably about the top speed. probably rapids. We'll see. I have no idea what it will do. But definitely 100 inches, 200 inches a minute will do it. So back to my design, I'm clear spanning 8 feet. Now I use some deflection calculators online to calculate deflection over that span and what tubing or beam I would need. And the minimum I calculated was 2x6 rectangular tubing, 3/16 wall to span that and not really deflect any more than, well, it's 100th of an inch or something, maybe. But then think about it, we're gonna have the gantry affixed to that beam as well. So if it happens to flex, so is the gantry. So it may be nil. I don't think it's flexing at all. I mean, I've stood on these things and bounced on them. They have no give at all. Clear spinning that. They're huge beams. And if I were to do this again, maybe I would probably just get I-beam. That would probably just be more straightforward, honestly. But the tube is fine. I bought that tube years ago. It's just been sitting around here for, like I said, I've been collecting parts for the CNC router for a long time now, and I finally got around to building it. And now, believe me, especially building this thing, in no way do I think I'm superior to anyone else. Jeez Lord, I've already screwed up a few things with this build. You learn as you go. But one thing I do think I'm doing better than some people I've seen, especially building out of steel, is I'm putting heavy duty pieces of steel where they need to be, and I'm not putting heavy steel where it doesn't need to be. So I've seen a couple of people building steel routers, and even their cross section is just supporting the plywood. They're using the same gigantic tubing spaced 12 inches apart, that they were using for their side rails and stuff. That's not needed at all, right? We're just supporting the plywood. It's a very spread out load, supporting a couple sheets of plywood. We don't need that. So I just use 2x3 angle iron for that. It's a 3/16 wall and very, very sturdy. So that's one thing I'm doing that I believe is a little better. Another thing I'm seeing, nobody's using any triangulation when they build their bases and just out of steel and stuff in general. I get it, when you weld steel together tubing, it's very, very stiff. It doesn't move. But still, we got a machine that's moving back and forth, and there's a lot of force on it. I want to see some angles, bracing and stuff. I don't see that. It's weird. But other than that, of course, there's many different designs you can do that will ultimately work extremely well. There's a lot of challenges that you face, like aligning things together, which I'm not there yet. I'm going to have to get a dial indicator to actually really make this thing accurate. It's a pain in the butt. There's a whole lot of stuff you don't know that you haven't thought about till you start building it. You can think about all you want, but once you start building it's stuff you don't think about until you're actually building it. It comes to be a problem. So I'm just thinking about things I wanted to get in here. I may have overlooked one other thing about my design that I like a lot so far is that with all the clear spanning I'm doing, I only have 4 points of contact to the ground, just things got 4 legs on it. This makes it extremely easy to level the machine out, and that's how I built it, by leveling it out, and I got leveling feet on it and stuff, so that makes it extremely easy. I see other people, especially when you use the dual ball screw design or rack and pinion or whatever, you're not clear spanning anything. You have multiple legs, multiple points of contact on the floor, 6 legs, 8 legs, whatever. Leveling that out is probably not easy. Although I'm sure you just built your machine if you did that, if you're doing it that way, just to be square as you can, and you have other points of adjustability. For me, my point of adjustability for my rails on my x-axis long ways is the actual table sort of tilting and giving a little bit, and it will, even if you jack up one side of it, just put a jacket and corn jacket up, it will lift that other side real fast, but there's a little bit of give, and I built it level, so it's already there, but there's a little bit of give where if we adjust these feet, it will tilt her and I can readjust it a little bit. So that's my point of adjustment. Other people's point of adjustment might be, whatever piece of support they have attached to it, shimming it or whatever. So tons of different ways to do it. No one right way to build these machines. Anyone claiming that there's only one right way to do any of this stuff is an idiot. Tons of different ways to do it. Whichever way you choose to do, that's for you. This is not the gantry video, so I'm not going to talk about the gantry, which I'm working on right now, but this is the base video for the table. Very important to get your foundation nice and solid and build up correctly. So let's go ahead and take a look at how I built the base for my CNC router. I started building the frame or the base or table for my CNC router, whatever you want to call it, with the legs from the ground up. And this is 3.5 by 3.5 inch square tubing, 120 or 1/8 inch wall. And I am notching the top part of these legs out to fit my 2x6 rectangular tube in, nice and neat and square. And I mean, I guess you could do a notch with a grinder, but that's definitely not going to be accurate at all. Can't do this with a regular cutoff saw. I have one of those. I actually just put a grinding disc. This is, what is this? A 10-inch grinding wheel on my table saw, which is made for 10-inch blades. But this is a 10-inch grinding disc, not exactly made for that. But I went ahead and put one on there. I've done this before. I've actually cut quite a bit of steel on this. Hate to admit it. And it works just fine, actually. It's very accurate for this stuff. You'll see when we get done here just how clean and straight these cuts are. I got this sliding miter thing that goes into the miter slot. It's like a sliding table that really helps with making this straight and smooth. And I just used the regular fence on the table saw to notch out the tubes long ways. And I'm stopping and checking to make sure a couple times that I'm not going too far. And I'm sure in the YouTube comments, the YouTube know-it-alls will criticize me for cutting steel on my table saw. No, let me tell you, it works just fine. Works great, actually. There is sawdust that you could possibly catch on fire. I cleaned the majority of that out. There's a little bit. Got a little, got a couple little whiffs of smoke going on the sawdust. You just want to make sure to stick around and supervise it for a while afterwards. Make sure you don't have a fire that's starting. And then here's the shot that will definitely shut up the critics. Look how nice and perfect those are cut. Try doing that with an angle grinder. So what's going on here now is I actually made one side already off camera because I was kind of making up as I go a little bit. I mean, I've sketched this out in CAD and I know what I'm doing, but still, whenever it comes to actually doing it, you gotta figure a few things out. So that's what a side of it looks like. Well, it actually looks like this. Turn the camera sideways. That's what it looks like. And now I cut out another piece of bar that goes right there. It's exactly the same length. So I'll make both sides exactly the same length, or the distance between the legs at least. So that's where I'm at now. And I'm going to show you how to do the second one, how I'm doing it. Got my leg. Already just drilled 4 holes roughly in it, and then we're gonna drill it through there. I'm gonna bolt it. Now I'm probably gonna end up welding it anyways, but at least the bolts gets me into position and provides some more holding. I wasn't gonna weld it, but I think I'm going to. So this is some footage of me drilling through the rectangular tube to attach these legs with 4 bolts, 4 half-inch bolts to be exact. I got one of those handy magnetic 90-degree angle holders to hold it nice and 90 degrees. And to be honest, this was all kind of moot in the end, but basically I started off just marking the center with the half-inch drill bit. And then I go to a smaller bit to get a smaller hole, because then smaller bits actually go through the steel a lot quicker. Then you go up to the big bit, and it just makes the process quicker than just going straight with a big bit. That's my pro tip for the day. But anyways, this whole thing was kind of moot. I mean, the bolts helped, but I ended up welding it anyways. I guess I should have welded it from the get-go. Although, as you'll see later, actually in the second part when we start talking about the gantry, when you weld stuff, it tends to shrink and tends to move things out of square. So maybe putting some bolts in at first wasn't such a bad idea. Now I'm going to guess not too many of you watching are welders in particular or have welded too much, but I'm using the cheap Harbor Freight Flux Core welder. And let me tell you, I've ran a lot of spools through this thing, and I can usually get a decent weld. But man, I have this Hobart flux core wire in it, and it is very bad. No matter what setting, no matter what speed, stick out, etc., anything, it just does nothing but stop and start and sputter. And look at all that. Look at all the splatter from that wire. I mean, you're usually going to get splatter from flux core, But this is just terrible. It's either a bad batch of wire or that wire is just bad in particular. I think this is the only time I've ever used it. I usually use Lincoln wire, and I had this other wire called KT Industries. But man, that Hobart wire is just bad. All these welds looked really bad. As you can hear in the background there, it's just sputtering and nothing. But I was trying to get it done. So now I'm cutting some 1.5" square tube on the cutoff saw at 45 degrees for some triangulation for the legs to brace this thing up and make it rock solid. This is one thing I was mentioning earlier, that I've never seen anyone that builds steel CNC routers on YouTube. I have not seen one person use any triangulation. And that's odd to me. I know, I get it. Once you weld steel together, it's very strong and hard to bend. It's very stiff, but man, you know, coming from building stuff out of wood, I sure like to add some 45s in there. Here's some more welding. Man, just the sound of that is making me cringe. Sounds so wet. And it's so odd sounding compared to the Lincoln wire I switched back to. You know, I finally got a roll of the good stuff. It's actually cheaper. Someone gave me a roll of this Hobart. I figured I'd use it. I figured it's all the same. But it's definitely not. And you know what? I'm working on that gantry right now. I haven't been filming a whole lot of welding shots. I'm going to have to do that just so you guys can hear the difference. How much smoother the Lincoln wire runs. Alright, so where I'm at now on the sides of the CNC machine, I got that welded in, obviously, and then I got these 45s welded at 1.5". I use 1 3/4 for that run, and then just 1.5" for those 45s. And then now I'm trying to make some leveling feet for these, right? So I stuck this piece of 1.5" tube on here. And what I'm going to do with that, you know, I have 2x3 tube. It would have covered this. What I was originally going to do was cut out a piece of like 1/4" plate I have and cover the whole thing. Two drawbacks to that is potentially you may have, with just a nut and a bolt in the middle, like this is essentially going to be my leveling feet here. A carriage bolt and some nuts, right? It's going to go right through there. We weld a nut. Have another nut to lock it. Those will be my leveling feet. Now if I had just plate, the plate might have some give to it. Probably not, but it might. And it would also trap moisture in there if I did that. So, and I have 2x3 tube, which would have been wider, but still left a gap. But think about that as well. That could have been, you know, that's only 1/8" wall. It could have some play up and down. So I use the 1.5" since the walls are as close as possible to the bolt, if that makes any sense, so it's stronger. Now I did use it this way, and I think the machine, big 150-pound gantry, is going to keep going back and forth and back and forth. It's going to put a lot of load on this thing this way, on this piece of tube essentially. So I'm probably going to cover these ends and weld a little piece here to secure that. I should have put them the other way, and why I didn't just put the tube this way is because I need this thing to stand up while I'm trying to put it together. Now another thing I'm doing, aside from the nut in the middle I'm welding on, actually thread this, I'm actually welding 2 more nuts, just dummy nuts, to the ends. It's just so that this thing can stand up on its own still until I get it roughly in place, and then I'll put the feet in. I'll jack it up a little bit or something, put the feet in, and start really leveling it out before I connect the 2 pieces. Alright, well I got the carriage bolt, put a nut on it, this will help keep it straight and centered. And I'm just going to weld that on there, roughly. So I know something that will drive you crazy if you're like an actual machinist by trade is that nut is not directly centered in there. I am one of these people, if it works, go with it. You know, the drill bit was kind of dancing around a little bit. I didn't center punch it. I sort of found the center, but then we got off a little bit. You know, it's not vitally important that these feet are directly centered in that tube. But it's going to work either way just fine. And I'm putting a lot of heat in that nut. And that's another thing. Once you weld a nut, you got to tap it back out. You'll see that here. I found that out the hard way. Bolts will get stuck in there pretty well, too, because they shrink. That'll work. Another good reason to actually leave the bolt in so you don't gunk up your threads.
So off camera, I started putting this side up. I'll show you me doing the other side, but I really had no idea what I was doing, so I just wanted to figure out what I'm doing first here. I just got the feet on. I jacked it up, basically. I clamped some 2x6 here. And I got a 2x4 clamped at the top. To kind of hold together roughly where I want it. Not at all accurate yet. But I put my 1/2 inch by 13 threads per inch bolts in the bottom, carriage bolts for feet, and I would like to set a piece of steel plate right under that bolt, even on this concrete block. And the concrete block's just to spread the load out a little bit on this floor. Who knows? I might just straight crack this floor or something if we get a lot of weight on there. But I know those concrete blocks are pretty tough. You can see I got this one sticking out further because I already know the floor slopes that way. That's just going to help level us up from the get-go. But we'll go ahead and get the other side going now. So after welding on those nuts, you get them too hot and they shrink. So you got to tap it back out. This kind of sucks. Alright, so it's time to start leveling this base up here. Got all leveling feet on. Got it on blocks. Like I said, I would like to put some little piece of steel plate right under those feet, but I think for now, just to get her welded up and squared up, I think we're okay. I got this Husky digital level. I believe the spec was this is supposedly accurate to 1/100th of an inch. I don't know, whatever. Even if it's a 1/10 of an inch, whatever. That's fine for me as long as we get this thing quite square. I'm gonna have to square it this way, that rail, that way. I'm gonna have to cut a piece of 2x3 tube here off, lay it across this way. Make sure we're squared up every which way. And I think as far as being square, I would say we'll be close, but once I get a piece of angle on this end and that end to start off with, we can move it around and make sure it's square that way. Other than that, making sure these legs are upright, square that way, 90 degrees. So there's a lot going on here that I'm going to be tinkering with.
In my position, right, if he came down those stairs and I had a chat with him, it was going to get violent really fast. He just had that look. And I said, I got nothing to say to you, man. I went on in the house and I told my girlfriend, I said, buddy next door, he's cracked. Don't stay clear of him. I said, he seems cracked. And next night he's knocking on the door. And she was over and she said, well, he's there at the door now.
So I got the angle tacked up on both sides here. 2x3 angle for the stringers to support the plywood. 16 inches on center. From here to there, as you can see, the last one, I just have a piece of 2x3 tubing going across. I was using it to level it out. Last one doesn't go all the way to the end. That's just because the table's longer than the 96 inches. She's pretty well leveled right now. Actually, you know, it was 0, 0 every which way. That way, that side, this way, and that way. The only thing I'm unsure about, I'm trying to work out now, especially is just squareness. This way, that, you know, the whole thing this way. Squared. It's a little tricky, but both these pieces of angle are exactly the same length, so as long as these are the same distance apart, I think we can be out a little bit. So I have no real reference point to except the legs, because these tubes were cut longer and off. I didn't use the ends of these. As you can see, that gap on the end's bigger than that gap because I didn't use the ends of these 2x6 rectangle tubes for any type of reference. Use the legs and the spacer pieces in the middle. So it's a little sketchy, but we'll get there. And the other thing I'm tweaking out is the vertical squareness, 90 degrees on the uprights. So trying to figure that out.
So now I'm tacking in some 1.5" tube braces at the bottom here on the short sides. And what I did, I just cut these to fit according to the length of the angle at top. And even if the thing ain't standing up straight yet, it should theoretically be like a parallelogram. So we can push it, and we're just going to tack it in. We got the top just tacked. So it'll still move side to side a bit to actually get it standing straight up, vertical 90 degrees, once we get these bottom bars tacked in. I'm actually using a ratchet strap to pull the legs together at the bottom and actually help me hold that tube in place while I weld it. Now I had actually switched my spool to this KT Industries flux core wire. I believe this stuff was from Tractor Supply. I don't know if they sell it anymore. I had a spool sitting in the closet, and this is the first time I ever used it that I can remember. Wow, this stuff was real smooth. Thing is, you can crank this wire speed any speed, and it seemed to weld at whatever wire speed nice and smooth, which is bad because you can actually get some cold lap. It will let you do a cold lap real easy, so you gotta watch out for that.
Look at this weld porn. $89 Harbor Freight weld porn, yo. Hashtag zero penetration. Nah, it was pretty hot. Got some base metal. I don't think it was as hot as it could have been, but yeah, funny. So before I start putting 45s on this and locking it in place this way, I need to square it up vertically. And thankfully the level is telling me that this bottom bar what I did is I've measured and fitted it from the top, and I scooted it down and made the legs the same length. So theoretically, that should be square, right? But that doesn't mean it's perfectly up and down. It can be skewed a little bit one way or another. Now, thankfully, it's telling me the whole thing needs to get pushed this way a little bit. This way at the top. So it's telling me it needs to get pushed at the top this way a little bit on both sides. So that's a good sign. So So what I'm going to do, I'm going to put a strap from that corner to this corner and pull it. It said 90 right on the nose. Ha! 90 right on the nose right there. And this side's 89.9. That's as good as we're going to get, man, the vertical. Vertical don't really matter that much since my rails on these X-axis, they're round so they can have some pivot to them. It's not that vital. I'll take a 0.1 of a degree. I just want to show you guys the levelness of the rest of the table since you didn't get to see it yet. And now this one's saying 0.1 right here. I'm going to assume that has something to do with me pulling it this way and pulling it for that bottom and stuff moving around. I'll have to adjust it again to get it back to 0. But 0.1, we can't complain. Let's look at these. These should still be 0 this way. Let's hope we're still there. Yeah, dead nuts. 0, 0. You see that? Dead nut 0, 0 there. Dead nut 0, 0 there again. And then let's check this one. Again, this one's saying 0. Went to 0, 0. Went to stop moving. That's cool. So we just got 0.1 over there. We got to adjust for from all this movement. This one went to 0.12. Oh, it's the same way too. So looks like the whole side just needs to come up a little bit now. We were zeroed out. It's alright. We readjust before I start welding these top ones in, which will kind of lock it in more. I should probably do that before I start putting the 45s on, zero it back out. That's the nice thing about making the CNC with just 4 corners instead of more legs in the middle, because we've got 4 points to adjust to level it. Now, like I was saying, the way I tack those angles in there to make sure they're perfectly flush and level, to get my table as perfectly flush and level, I clamped into that 2x3 and laid that across there just like this. The 2x3 is longer to lay on the side rails. Stuck it on there and then tacked them in place. So that's perfectly flush. And of course, we'll surface the table anyways. Doesn't matter if it's off a little bit, but it's better to be accurate than not.
So after putting the ratchet strap on there and getting it vertical, nice and level, cut some 45-degree 1.5" square tubing to weld those in and lock it in place. And boy, that does the trick. Definitely locks it in place when you put those on there. I had previously painted these huge 2x6 rectangular tubes to protect the outside from rust. Since I have center off so long, so I had to grind off some of that with a wire wheel so I can weld the rest of these stringers in, which I'm doing right there. And like I said, I just attached them to a 2x3 piece of tube and set that on top, clamped into it, and then tacked them in place and weld them in from there.
Alright, so at this point what I did, I ground down all the welds to make it flat, and I just stuck some paint on the top of it, a little bit of cheap spray paint I just had sitting around. Actually, it was Rust-Oleum. I don't want to use cheap spray paint, at least for the base coat. Try to get some rust protection on the outside, of course. The inside of these tubes are going to be susceptible to rust. Try to keep it in a lower humidity environment. This is 3/16 wall, so I don't know. You know, you could seal up the ends of this, but then I'm tapping and threading into it, so it's not going to be totally sealed anyways. If you seal up a tube, eventually the rust will use up all the oxygen, and then it won't rust anymore, right? But, like I said, we're going to have all these screws into this, so I don't think that's going to be possible anyways. So this thing will just be susceptible to rust on the inside of these tubes, and I don't know, it might last 15 years. So unless I keep it in a real low humidity environment, which out here that's not going to be. We'll see if we move it somewhere in the future or something. But so here's a sheet of OSB I just put on top. Now this is obviously not the decking. You know, speaking of that, I'm probably going to use MDF just because it comes in 49 by 97 instead of 48 by 96, and that extra inch will do me a lot. I wanted to use plywood, actually a nice quality plywood, as the base first because I think it's stronger, and then stack a MDF on top of that to be surfaced. But I think we'll just do 2 layers of MDF. But anyway, this is just a thin sheet of OSB. This is just to build the gantry on. Since I have a nice flat level surface here, I'm going to level it out again, make sure it's perfect. That'll make building the gantry extremely easy, since I can just lay all the parts out on here and weld them together, and it should come out quite true. A lot better than just guessing and using angles and stuff. You know, squares and all that crap. Which, I mean, I'll use that stuff, obviously, but I mean, as far as laying it down flat, it'll be square. And man, this stuff, it's solid as a rock. I actually got up on here and jumped on these 2x3 angle irons. Those are 3/16 wall, if I never told you. I was standing right on those suckers and jumping on it. I can't feel any deflection. It's solid as a rock. All they got to do is hold up a piece of plywood anyways, or 3 sheets essentially. So that ain't nothing. So it's a nicely spread out load. And then when I get the actual MDF on here, we'll drill and tap into this to secure it down. But that's for the next video though. We're going to build the gantry. And we're going to build the gantry in the next video.
Here's a little bit of bonus video. This is me welding. I was using a natural density filter instead of like a shade, you know, that you normally use for welding. I was using a natural density filter in front of my camera. And, you know, you can see a little bit of the puddle, like, you know, red, but there's not a real big puddle. It makes it look really cold. It might be pretty cold. I mean, I thought it was really. Now you can see it. You can see it biting off the edge there. Yeah, you can see the puddle if you look at the edge. Yeah, it's biting in. There's a puddle there. It's just not showing up that well. So I guess it's not that cold. I didn't think it was. Yeah, that's some of the welding coming out. I'll show you here after I clean it off and what that one looked like.
Wire wheel it and see what we got here. I'm real happy with that one. That came out pretty nice.
That's not too bad, really. I actually like welding with a gap because you can really get it in there and get some penetration, especially with a low-powered welder. Except for that little piece of porosity there. I didn't quite hit the edge at that spot in the middle. But overall, not bad. I mean, it's not passing any inspections and stuff. But for a $90 welder with someone that doesn't know how to weld, You can see it's got a bump at the beginning where I was sitting for a little bit, but started moving. It started filling in there, laying pretty flat. I'll take it.